The second part of 12.2 is going to be talking about radians. So radians is another way to measure angles inside of a circle. And it is important that you know that 1 radian is the measure of an angle in standard position whose terminal side intercepts an arc of the length r. So the length of this arc on the outside is the same as the radius, and that is what a radian is. When we are talking about radians, the entire circle is going to be 2 pi r, and that's because that's our circumference formula, sorry about that. And if we use our unit circle, so our unit circle is when our radius equals 1, that's going to tell us the entire circle is 2 pi. So we're going to do more with the unit circle next lesson. But it is going to be important that we know some of these angles. So for radians, we are going to reference it in terms of pi. So they just told us the entire circle is 2 pi units. So that means if we take half of the circle, because the whole thing is 2 pi, half of the circle would be pi. And then if we take half of the pi, that would just be pi over 2. And we know that these are equal to 90 degrees and then 180 degrees. So with this one, we went from here to here, and that was pi over 2, or 1 pi over 2. And then when we went another 90 degrees, that's the same thing as saying 2 pi over 2, which just simplifies to pi. Then if we go another 90 degrees, so if we're counting, we had 1 pi over 2, 2 pi over 2, now we would have 3 pi over 2. And then if we went another 90 degrees, that one would be 4 pi over 2, which we know 4 divided by 2 is 2 pi. So these are equal to each other. So every time we are counting, we're just counting in our terms of fractions. We are going to do more practice with this next time, but to start, those are the angles we are going to be working with. And then we know this one, 3 pi over 2, would have to be 270 degrees. Now, the way that you can convert between radians and degrees is using that information from that unit circle. So if we're going to write a degree measure in radians, we're going to multiply by pi radians over 180 degrees. And then if we want to write radians as degrees, we're going to write that as 180 degrees over pi radians. And when you write this, you don't have to actually write the word radians, you can just write pi. With these, if you've ever done unit conversions, this is exactly what this is. It's unit conversion. So if we do some examples for number 3, they want us to convert between radians and degrees. This would be on the no calculator part of the test. So you do need to make sure you can simplify these fractions without a calculator. So if we start with the 110 degrees, we are going to multiply this by our conversion. And because it's in degrees, we want the 180 degrees to be on the bottom of our fraction that we are going to use to convert to radians. The reason for this is 110 degrees is the same thing as 110 over 1. And when we're multiplying, we just multiply straight across. So that means we have a degree unit on the top and the degree unit on the bottom, which are going to cancel each other out. So then we are no longer working with degrees. And 180 is equal to pi radians. So because they're equal to each other, this is the same thing as multiplying by 1. We're just changing what units we're working with. So then again, we're going to multiply straight across, and this would give us 110 pi over 180. Then we're going to simplify. If you have two numbers, one on the top and the bottom, that both end with 0, you can get rid of the zeros on the end because that's the same thing as dividing by 10. Then we want to look 11 and 18. We want to check, are there any common factors we can divide those both by? And then if there are not, which there are none, we would just then write our simplified answer as 11 pi over 18. Now our angle is in radians instead of degrees. Okay, so then for example B, this time we're starting with radians, and they want us to switch it 2 degrees. So now, because we have pi on top, when we multiply by the unit conversion, we want pi to be on the bottom, because the pi should always be able to cancel each other out. If you have a pi squared or multiple pi's in your final answer, you probably have your fraction upside down for the 180 and the pi, and you need to switch it so that the pi's will simplify with each other. So if we were to multiply straight across, we would have a negative 180 pi over 9 pi. And again, because there's a pi on the top and the bottom, we can simplify those together. And then if we take 180 divided by 9, I know 18 divided by 9 is 2. So 180 divided by 9 would be 20. And don't forget your negative sign with it. So this one, would be negative 20. And then our degree symbol, because we did have that degrees on the top. And that's our answer. Okay, so you should pause and try the next one on your own and then check your answer. Okay, so for example C, we had pi over 6, and because I'm changing to degrees, I would have 180 on top over pi. Now, when you're simplifying, if you want to simplify the pi's before you even multiply, that is okay. You will still get the same answer. So then we would have 180 degrees over 6. And then 18 divided by 6 would be 3. So 180 divided by 6 is going to be 30. And that gives us our answer of 30 degrees. So that's how you're going to convert between radians and degrees. This will be useful for multiple different things. It is going to help us evaluate trig ratios and trig functions a lot. It's also used when we're talking about arc length and area of a sector. So the arc length is what we are going to be focusing on. So this formula here, where we have S equals R times theta. And it's important to know that theta is a central angle. So that just means it starts at the center of the circle and intercepts the arc. And that angle needs to be measured in radians when we do this. So we need to make sure our angles in radians before we plug it into the formula. This area, or the arc length formula, will need to be memorized. You do not need to worry about the area of the sector formula. We are not going to be working on those this chapter. So looking at that, example 4 is using this information. They want to find the arc length, and then we can cross off area of a sector with a radius of 9 and a central angle of 60 degrees. This would, again, be on the no calculator part. So before we can use our formula, we know that the angle needs to be in radians, and right now it's in degrees. So we're going to use our previous information from the last part to change this to radians. So because I want it to be radians and I want the degrees to cancel out, I'm going to put the degrees on the bottom so those units are gone. And then I would have 60 pi over 180. Both of these numbers end with 0, so I can divide them by 10 and get rid of the zeros. And then I know 6 is divisible by 6, and so is 18. When you are simplifying these, you want to be careful. A common mistake is that people would say this would be 3 pi. But if we simplify our fraction, we would get 1 pi, sorry, this keeps jumping around. Okay, so 6 divided by 6 would be 1 pi, or just pi, over, and then 18 divided by 6 would be 3. So it should be pi over 3. Make sure you are not switching where the larger number is in your fraction, because that changes the value. Once we have that, now that it's in radians, we can find the arc length, which is the formula S equals R theta. So the arc length S is going to be equal to our radius of 9 multiplied by our angle theta, which we found to be pi over 3. When you multiply a whole number by a fraction, it gets multiplied by just the top. So we would have 9 pi over 3. And then we can simplify 9 divided by 3, and that is going to equal 3 pi. This is a length, so if we were to label it, it would just be centimeters, not squared, because it's not an area. And that is your final answer.